Hello everyone, welcome to Programming Knowledge. So I again welcome you all to yet another tutorial Programming Knowledge. So let's get started with today's tutorial. You all can refer to this link github.com/pro software development and move to this repository competitive coding Python. Here you will get all the codes which are implemented prior to this tutorial, and you can run this code on your local machine. So let's get started with today's tutorial. So today's tutorial is about Dijkstra algorithm for weighted directed graph. So this is a very famous algorithm, and this is used to implement single source shortest path for weighted directed graph or Dijkstra algorithm. So what you can do, let's see a basic difference. Single source shortest path is Dijkstra algorithm, and this is a greedy approach. Okay, a greedy approach, and all source shortest path is Floyd-Warshall algorithm. So this is about Floyd-Warshall algorithm, and uh, uh, I can tell you that this one is a basically a kind of dynamic programming approach. So Floyd-Warshall is used to generate is a dynamic programming approach. So here I can type dynamic programming. Okay, so this is dynamic programming, and this is a single source shortest path is a Dijkstra algorithm, that is a greedy approach, and this is a dynamic programming approach. And then now I can show you a graph. So we would implement what we need to implement. We can take a source destination and a source and a destination. So let this be the source and this be the destination. Now if we want to move from source to destination, we can use two paths. The first one is this path, we can clearly see, and the cost of this path is 4 plus 10 is equal to 14. And we can use this path also, uh, sorry, uh, this one, and the cost of this path is 2 plus 3 plus 4, that is 2 plus 3 is equal to 5 and 5 plus 4 is equal to 9. Okay, so let's implement this algorithm. First we would construct a weighted directed graph. I also have the test case for this graph. This is the same test case which we had seen in this picture. Okay, now we move to the code, and let's code this algorithm. So the essential data structure we are going to use is a heap. So we are going to use inbuilt heaps, and I also explain why we are using heap in this algorithm. But just remember one thing, this is a greedy algorithm, and I'll just explain while coding that what is greedy algorithm and why we are using this heap data structure along with greedy algorithm. So both are interrelated, and you will get the uh, 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 clue where why we need this data structure. So let's implement a graph. Graph is equal to default dict of list. So we can create a graph of default dict of list. Then b comma e is equal to map int comma input dot split. Then for I in range e, we get u comma v comma w is equal to map str. We get input dot split, and then graph of u dot append v comma int w. So we are implementing a tuple here, but we need to implement v comma int w. Then what we need to take a source comma destination is equal to map str input dot split. So this is and then we call the function generate shortest path. We take the graph comma source comma and destination. We send this parameter. Now we implement a function shortest path, like define shortest path. We take a graph as a parameter, then source comma destination. Okay, and then we try to define this, and I'll quickly write this is a we all know this is a greedy approach. Then I'll explain why we are using a heap. So let's take h as a heap, then heap q dot heap push, then we push a tuple into h, on which tuple we are going to implement 0 comma source. Now I'll tell you why we are using heap. So this is the key line. First, heap heap will be able to maintain all the vertices which we are pushing into it. So if we push the source here, so it will like as soon as we push all other vertices, it will keep a track record of the source, plus it will keep the track record all the vertices, or the vertices we push into it. So it will keep a track track record of vertices with cost, and update them as well. So it will keep a track record of vertices with cost. This is the first thing. Plus, when we pop, heap pop will return vertex with least cost, and heap pop will return the vertex with least cost. First, it keeps a track of vertices with the cost, and then heap pop will return the vertex with least cost. Then, since this is a greedy approach, we try to get minimum. Actually, we are going to implement this like this. This is our source. We get minimum, then minimum, then minimum, and when either if we reach the destination, then we break our algorithm. So this is our greedy approach works like this. We are from source, we move to minimum, 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 and if we reach the destination, we break our algorithm. This is the termination condition, or either if heap is empty, either if the heap is empty, then we also break the algorithm. So this is the case why we use heap. Then path is equal to, we generate an array for path, then while len h is equal to 0. If heap is not equal to 0, then we continue with the algorithm. Current cost comma current vertex is equal to heap q dot heap pop h. I told you this would return the current cost and current vertex with least cost. Okay. Now if we check if current vertex or current vertex is equal to destination, then we break. And before this break statement, I would put print path exists with cost. This would be our cost dot format. You can say current cost. Okay. So either we can do like this also, source comma destination. So this would return the else what we do for neighbor comma neighbor cost in graph of current vertex. So this is like something very similar to what if you followed my tutorial on depth first search or breadth first search. So this line would be very much similar, but in this case we also include cost. Then heap q dot heap push heap comma current cost plus neighbor cost and then the neighbor. So I hope this algorithm is clear. So uh, let's uh, we let's like this is I think not required since we are not generating the part. First we are checking for the condition if the path exists or not. So let's run this code. Let me copy the test case here. Yeah, so here you can see perfectly fine. Path exists A to D with cost 9. So here you can like this is a base. This is a very nice way to implement Dijkstra algorithm, but you need to manipulate this uh, algorithm with certain requirements. Like you need to put some if conditions according to your need when you get such questions with shortest path algorithm. So you can have a hint like this is the code we need to execute, but you need to implement some modifications. So thank you guys. Thank you so much. I'll catch you in the next tutorial. So thank you guys. Thank you so much.